Hi, I'm Tracy Kijewski-Correa at the University of Notre Dame and director of the StEER network. And I'm pleased to offer this video giving a brief insight into the role of reconnaissance as one of the major elements of the NHERI Science Plan. Tragically, disasters provide the one opportunity to faithfully study the complex interaction between natural, built, and human systems. We simply cannot capture these complex dynamics in a single experiment or computer simulation. And as a result, post-event data collection is critical to document the painful lessons and victories revealed by each disaster. Now, those insights inform ongoing research and development that may result in new mitigation strategies, innovative systems and materials, or reforms of building codes and construction practices. Of course, all that discovery means nothing if we don't effectively translate this knowledge to help communities build back better and ideally build better before the next disaster strikes. Thus, post-event data collection is literally the starting point, but certainly not the end, of a critical cycle that reduces the toll of disaster on society. However, in order for that data to effectively drive this learning process, we need to build our capacity to more effectively collect and share that data. And for me, this centers on 5 practices. First, have a sampling strategy and know the rationale behind it, informed by how the data will be used and potentially reused. For example, we cannot estimate probabilities of failure if we only document the damaged buildings. We need a representative sample of all levels of damage, and that includes the undamaged structures. Secondly, we need to leverage open data to the greatest extent possible to design our sample. Being in the field is overwhelming and filled with challenges, but building proficiency in querying and integrating remote sensing data, building inventory data, and hindcasts of the hazard event can help identify where you should focus the data collection efforts well before you ever go into the field. Next, standardize your data collection processes and instruments, so each observation is collected to a consistent and repeatable standard. Now, this is especially critical for damage ratings. Those standards should include processes for quality controlling the data after you return from the field. Fourth, document your data thoroughly. Release documentation that helps the user understand how the data was collected, post-processed, and ultimately organized on DesignSafe. And that leads me to the 5th point: publish your data on DesignSafe and secure that DOI. Include it on your CV. Include it in your annual reports to your supervisors. And when you use the data of others, cite their DOIs. We need to change the culture around valuing data as a legitimate research product. And that begins not only with being good generators of data, but also good reusers of data ourselves. That means being a good data citizen. Now, through StEER, we have worked to institutionalize those 5 principles within the structural engineering community. And those principles have helped us then create data sets that have been reused for a number of applications, from improving loss modeling capabilities to training machine learning algorithms that can further automate our discovery process. However, one of my favorite examples of post-disaster data having impacts was the work we conducted after the 2021 Haiti earthquake. Now, unlike 2010, this earthquake affected a wider swath of communities, ones that were even still recovering from 2016's Hurricane Matthew. These communities were more remote and challenging to reach. Security conditions would not allow StEER or other international reconnaissance teams to safely enter Haiti to assess the damages. But with quick work, we redesigned our mobile app and adapted it to the Haitian building typologies as part of what we would eventually call a hybrid assessment protocol. We recruited teams of Haitians who were not engineers but knew the affected areas well. And they would download our Fulcrum app onto their Android smartphones and complete the first half of a simplified bilingual assessment process. And that focused on geolocating the building, gathering some basic information on that building, and capturing a sequence of photographs. That data would then pour into the back end where our team was waiting to process it. There from the United States, we would audio translate any dictations that were there with the record, as well as quality control the records to get them ready to move out to our assessment teams. And then we would feed it into a worldwide network of volunteers that included the UK's EFIT, which would remotely complete an assessment that reviewed the pictures and other data to classify the building typology and the damage level observed. Now, our initial effort under StEER was soon scaled up in partnership with Geohazards International under a cooperative agreement with USGS and USAID. The effort resulted in over 12,700 building assessments, including schools and other critical facilities, reaching areas inaccessible to official damage assessment teams led by the UN and the government of Haiti. And we opened this data set to governmental, non-governmental, and academic stakeholders. In parallel, we spun up a second mobile app to generate over 2,000 Did You Feel It assessments, so USGS could use that information to generate macroseismic intensity maps for the affected area, which would compensate for the lack of ground motion records observed that day. Importantly, this dataset became the basis for a major World Bank study, where machine learning was even used to mine tens of thousands of photographs in our database to extract learnings that would ultimately inform the recovery of housing in Haiti. But perhaps more importantly, the event prompted the reconnaissance community to consider more intentionally how we might localize our efforts, working in partnership with local engineers and in even this case, with local community members, and benefit from the valuable knowledge that they bring. So thank you for taking a moment to engage with this video. I hope you get some idea of what has been and what will be possible through NHERI in the area of reconnaissance under the new science plan.